Hello, this is Angel Flores, and this is my video submission for video assignment number 1 for Math 2820. I will be solving question 1. The skewness of a random variable x is defined as the expression, where mu is the expectation of x and sigma is square root of the variance of x. Find no value of n and p that would cause a binomial random variable to have zero skewness. So we can start by writing the expression and expanding it using very simple distribution, which is pretty self-explanatory. Not that I need to go too much further into detail. Notice that sigma is a constant though. So this expression that we have right here can be written as expected value of something over here over sigma cubed, and we can bring the sigma cube out of the expression essentially. And so that is what I did in this step right here, is just take out the sigma cube so that way I can continue expanding the expression and simplifying as need be, and combining like terms whenever I see them. So these two are like terms, and then these two are like terms. We can combine those two. By linearity of expectation, aka expected value of x plus y is equal to expected value of x plus expected value of y, we can apply the expectation separately. So that is exactly what I did, applying the expectation to the x cubed and then to the x squared 3 mu expression, but we can take out the 3 mu since this just represents a constant. And same thing with the other terms in here. Notice that variance of x is equal to the expected value of the second moment of x minus expected value of x squared. And it can be rewritten as this expression right here. And this could be represented in terms of sigma and mu notation as sigma squared plus mu squared is equal to expected value of x squared. And so that is exactly what I did here for this step, is replace the expected value of x squared with that expression that I outlined. And then just a distribution. And so now we can continue simplifying the expression, and eventually we get to this. And this is at the point where we set the expression equal to 0, since we are solving for skewness of 0. But now at this point, we must consider the expression in terms of the binomial random variables n and p. So some things to know is that the expected value of x is equal to mu, the expected, which is just n times p. The variance of x, which we represented as sigma squared, is represented as n times p times 1 minus p, and sigma is just the square root of that expression. And so with that, now we can go ahead and start simplifying. But first, we must use the moment generating function to calculate the third moment of x, which we currently do not know what it is. So essentially, I wrote the moment generating function, which is just the expected value of e to the power of tx right here. And this is the expression that we get, e to the power of t times p plus 1 minus p to the power of n. And so first, we take the first derivative, and we get this expression. We take the second derivative and we get this expression, and these two expressions we can use to also find the expected value of x and x squared, but we didn't need to do that since we already know those terms. What we're more interested in is the third derivative of the moment generating function, which is this very, very long expression that I'm not going to explain, but that is the way to calculate it. And the expected value of x cubed is just that third derivative of the moment generating function and when t is equal to 0. And so we get this as a result of our simplification, and then just doing a bit of cleanup to make this expression look nicer. I just combined a few like terms. So this one and this one, for instance, are like terms. We get 3np squared times n minus 1, and so on and so forth. And so let's go back to the question that we were solving. So we were trying to determine the skewness is equal to 0. And we have this expression now. And so now we can substitute everything in terms of n and p and continue with our problem. And so some other things that I did here is negative 3 mu sigma squared, which is this expression term right here, can be simplified to this. And negative mu cubed is just negative n cubed times p cubed. So now we substitute everything, and this is what we get essentially right here. I highlighted or underlined, I should say, some of the like terms to make it more visually noticeable that we can combine a lot of these terms and a lot of them cancel out. So there's 3n squared p and p squared with the negative 3 cancels out. This -3 and -3n squared p cubed also zeros out, and same thing with the n cubed p cubed terms. And so now we're left with this expression right here that is much simpler and much nicer to look at. And notice I didn't simplify immediately the sigma cube. That was just to save space and not have to rewrite the same expression multiple times. But now we can substitute in with what we would expect. So now let's simplify the expression inside the brackets. So what I mean is this expression right here. I just rewrote it over here. And we can see that we can take out an n times p, and we get this expression right here. And this expression right here can be factored out into 2p minus 1 and p minus 1. And we're going to take a negative out from this expression in particular to get 1 minus p, because as you will see, we'll be able to do some simplification. So substituting back, we get this expression now. And we can cancel out the np's and the 1 minus p's to get 1 minus 2p over the square root of np times 1 minus p is equal to 0. And at this point, two expressions must hold true. One, that the denominator must not equal to 0, and the other is that the numerator must equal to 0 for this to hold true. And so we're going to solve the right expression first, which is just p is equal to 1/2. And for the left expression, after substituting p into over here, we get 1/2 times square root of n is not equal to 0, which essentially means that the square root of n must not equal to 0. And so this holds true for n not 0, that it is greater than 0. And so the answer to this problem is the values of p is equal to 1/2 and all values of n greater than 0, not equal to 0, are what make a binomial random variable have 0 skewness. Thank you.